All right, thanks everybody for joining. We've had a little bit of a gap due to the summer months, but we have a couple of talks scheduled in the next couple of weeks here. And I think it's safe to say this is now an annual tradition where we're able to welcome Ed and his team from the University of Michigan to talk about the work that they've been doing this summer on the perfSONAR project. I want to say this is the third or the fourth, Ed. I think almost every single year you've done this. And this year we're welcoming Ed as well as Benton and Kaifeng. And they are going to be talking about the ongoing work on perfSONAR 5, specifically talking about Wi-Fi metrics with PSSID. So I'm going to turn it over to Ed to drive, and then he will bring in Benton and Kaifeng to give the presentation.
Thank you very much, Jason. I'm Ed Colone at the University of Michigan here. Benton, Kaifeng, and I work for Dr. Eric Boyd. We represent the network monitoring interests in the University of Michigan, which is a member of the perfSONAR consortium. A lot of the other members are more ISP based, so up till now Wi-Fi hasn't gotten the same level of attention. But as we are a campus and we have a very large distributed Wi-Fi environment, which is now we're going through an upgrade, and we're hoping to be able to monitor the progress and abilities of that upgrade. So we are presenting to you our work that we're doing with perfSONAR in the wireless metric gathering space. And we have a product we call PSSID to kind of keep with the perfSONAR nomenclature and to also sort of discuss that this is SSID based. And with that, I'm going to turn it over to Kaifeng.
Hello, I'm Kaifeng. I'll be talking about the context of our problem and the motivation for PSSID. So modern distributed Wi-Fi environments, as we know, are very complex. Within an organization, we may be having multiple access points. And that is the result of we are running multiple SSID at the same time. For example, at the University of Michigan, we're having Azure Roam and wireless MGuest. All of these SSIDs are working at the same time. And also they're running on different frequencies. We have 2.4 gigahertz frequency and also 5 gigs, which means that there'll be a lot of pieces running at the same time. And we also need to measure the different performance for the network for all of these SSIDs. And relying on signal strength as the only metric can be very misleading because it doesn't tell the full story. It is pretty easy to detect the complete outages, but and also redundant infrastructure can also lead to additional problems for detecting a problem, because even if the signal is good or we can have the connection, we are unaware of the individual component failures, so which we cannot go and check on these failed hardware because we're oftentimes unaware and they're uncovered by the redundancy. There can also be difficulty connecting to the internet, and this difficulty can take place within the organization or outside the organization. That makes it more difficult to locate these problems. So in order to really benchmark the entire network performance, we had to do it from the user perspective. And that's why we are having PSSID. So let's walk through a sample scenario. So in this scenario, we are placing a PSSID node within an area that has weak AP signal coverage. And we'll do a thing called passive scanning, which is we'll be scanning all the SSIDs and networks around us. That is achieved by using a pscheduler plugin, which is called Wi-Fi PSSID. We'll be scanning all the SSIDs and access points within the range, and it will tell us the channel these SSIDs are running, their signal strength, and if to tell us if there is sufficient coverage or not in that area. And then after we gather all of these available SSIDs that are adjacent to us, we can do some actual testing on these networks. Will be for each of those SSID pieces, we'll be getting on the network and run a suite of tests over the internet. And we'll be correlating the test result with the pieces, which represents individual access points. The example test, some tests that we can run on this stage can be throughput, latency, and some application level tests such as HTTP DNS. For example, a user might want to know if they can get on Google or not. And this is on the application level. So to sum up the two stages of testing, we have a passive scanning part where we detect the network around us, and we also have an active part that we need to actually do the testing by connecting to each individual access points to see if we can get strong, good enough internet from all of them. And a lot of these new features from PSSID are dependent on the new features that will be coming up in perfSONAR 5.0. And the most important part of PSS update relies on the batch processor, which can schedule different tests in parallel. The test can be exclusive or non-exclusive. And definition of a batch is that a batch will be containing more than one job, and a job can contain more than one test. And we can also rely on a continue if flag, and that is a condition that if a previous test is successful, then we run the second test. If it is not, we stop testing, which will save us a lot more time. And there are like several new plugins and tests that are available for 5.0, which will be BSSID which is the SSID scanning that we use when we gather all of the networks around us, and then .1x, which is layer 2 authentication, and DHCP, which is layer 3 in obtaining an IP address. And perfSONAR 5.0 will become available on Ubuntu 18 and 20. And here is our introduction to and more information about PSSID. And the PSSID is an open source software developed at University of Michigan, and is a Wi-Fi SSID basis scanning testing orchestrator, which means that PSSID will be controlling pscheduler and asking pscheduler to do all the tests for us. So what you can do, what its purpose is to detect all the SSID bases in an area, and then do all these testing. It also features a dashboard that we can use to analyze metrics, and it has built-in deployment system in mind, so that we can do a large scale deployment on a low cost probe, which is a Raspberry Pi 4 at the moment. And the software was written using Python, and also relies on other source software such as ELK and perfSONAR. And here is the detailed PSSID 2.0 algorithm. So we'll be first reading the config file on the startup of the software, and the config file can be generated by the GUI, by a software that will be talked in detail later. And then we'll be scanning for nearby access points, scanning all of these pieces, and then we'll be filtering these pieces based on one metric, which is or other metrics to see, and the metric can be if the signal is enough, or if is the SSID that we want to run tests on. After we have a list of all of those access points that we want to run the tests on, we can generate a batch of tests that we define for all of these tests. And then we'll be calling pscheduler using the batch processor to run the actual measurement. And then after the measurement has been completed, will be returned from pscheduler and will gather the results and send them to ELK for further data analysis. And here's a diagram that details summarizes the workflow, and it highlights the differences between the PSSID on perfSONAR 4 and on perfSONAR 5. So on perfSONAR 4, we are running all of this tests one by one, which means that even though some of the tests are non-exclusive, which means that you can run DNS and HTTP at the same time, and they will not influence each other. But if you are running throughput, that is taking up the network resources for the interface and for the machine. So you do not want to run throughput along with other tests. And so for SONAR 4.5, we have this distinction between exclusive test and non-exclusive test. So you can take a look at the diagram on the right. We are running throughput before all these other tests. Throughput will be an exclusive test, and DNS, HTTP, and all these tests can be non-exclusive, which means that by running those non-exclusive tests in parallel, we will be saving a lot of time, and it simplifies our process, and we can get our results more efficiently and faster. So let's run down an example that shows how we are going to run this batch command. So first of all, we will be doing a layer 2 authentication. So we will see if we can get on this network, and we will be authenticating ourselves using credentials that are defined in the configuration file. So there is also a container if part that is defined in the configuration, which means that if the authentication fails, then we stop running other measurements. If it succeeds, then we proceed. So we can also specify the PSSID for the test because we want to run the testing on each individual access points. So we have to have the ability to specify specific PSSIDs. And for the next job, we are doing a layer 3 authentication, which means we are going to request an IP address from the DHCP server on the network. And after we obtain an IP address from the network, which means we are finally on the internet, and then we can run other tests. And you can see here that we have logged onto the network and we obtain an IP address from DHCP server. And once this test is successful, we go to job 3, which contains other tests. And in this example, we have round trip time and HTTP. Here, we can run multiple tests that are non-exclusive, which means we'll be running all these tests in parallel. And here, RTT and HTTP are running in parallel. So we can not only run the test in a lower level, but we can also run the test in the application layer level, which is you can see here, we can run an HTTP test to Google to see if it's working. You see, check if the user can get on Google. And then we can look at the results that are returning from the test here. And then after the results are returned from pscheduler, we gather them and send them into ELK or the dashboard for further analysis. And yeah, that's pretty much how PSSID works in detail. And now Benton is going to talk about how PSSID is deployed, and from the network administrative perspective, how the system is going to be provisioned and used.
Gotta mute yourself. All right, so Kaifeng talked about, well, Kaifeng worked on PSSID itself, whereas I worked on more of the surrounding kind of infrastructure for it. So the main two things I was working on were PSSID GUI, which is used to manage and push config files for PSSID out, and then the ELK stack stuff, which is used to view and monitor the results of PSSID tests. So to go into how you set up the system. So we have a Ansible playbook on GitHub to deploy PSSID GUI itself and the elk stack, and they're both packaged in Docker, so it's relatively simple. And then, so first you send those out to 2 servers or 1 server, and then to bootstrap the Raspberry Pis themselves, you need the operating system, then the software, which is like PSSID itself, pscheduler. Then you need an initial config file for PSSID, and then it's the elk tokens. So elk requires a token for you to push data in so that anyone can't just push stuff in. And then, so that's how you set it up. How it's used is first a Wi-Fi admin can go into PSSID GUI and configure config files for PSSID. And then using Ansible, well, so PSSID GUI actually generates Ansible inventories. Then using Ansible, a Wi-Fi admin can go in and use the inventory to generate config files and push them out to all the Wi-Fi probes. And then those Wi-Fi probes will send the results of those tests to the elk stack so the Wi-Fi admin can monitor the results of the tests. So to set up a Raspberry Pi in the field, it needs PSSID, pscheduler, and then it needs the PSSID config file and the elk credentials. And once it's in the field, then because the Raspberry Pis have power over Ethernet, they can be managed through the wired interface, and they can be power cycled through the wired interface, and then we can push the configuration for PSSID through the wired interface and do provisioning of the software itself over the wired interface. And then the wireless interface is just used for monitoring. And then the wired interface is 1 gig, so that could be used for monitoring as well, but primarily the Wi-Fi is used for monitoring. So the reason we chose to use Raspberry Pis themselves is the Raspberry Pi 4s have really good wireless hardware. And then also they have power over Ethernet, which is useful. And the power over Ethernet, like I said, is 1 gig. So even though it's primarily used for, we primarily are using them for wireless monitoring, you can use the wired for monitoring as well. So this setup for the Pis pre-pandemic is $100, which is great. Of course, we found a Armored Pi case which blocks all of the ports except for the Ethernet port, which is perfect. And with a power over Ethernet hat, you can get PoE through the Ethernet line. So the Ethernet is the only port exposed. So it's perfect for our use case. So the structure of PSSID GUI itself. So the front end is written in Vue, and the backend is written in Django. So the Django backend actually interacts with the disk and saves the inventories. And then it's served with a Gunicorn server. And the entire project is packaged in Docker. So the Ansible deployment is really simple. You just send out the Docker container and it just works. So the config file that PSSID GUI generates, this is a like mental map of how it's structured. These are the different sections. So I'll go through PSSID GUI and show how each of these sections are configured using the GUI. So the first section is the inventories. Using the GUI, you can configure multiple separate inventories, and then when you push configs, you can choose which inventory you want to use to generate and push the config files. And then the inventories can be managed with version control easily, both backing them up and like pulling them down into the GUI. So that's useful. For archivers, you can specify any arbitrary parameters to be passed into pscheduler for the archivers, and you can save the settings as a different archiver. So if you set up like the elk stack IP address and everything, then you can save that input configuration so it's easier to use. Next is the schedule. So it's scheduled using cron syntax. So you can of course do like, however many times a day or whatever, But then you can also do, like, if you had two classes, if you had a class that happens 2 times a week and they have Wi-Fi problems, you could set the schedule to run every 10 minutes during those 2 class periods during the week to narrow down on that problem. Then this section is for configuring BSID scans to passively scan for the BSIDs that are online, and you can set a schedule for the scans, and then you can choose which interface you want to use to scan. The SSID profiles are just a section where you can set up a way to discriminate which SSID you want to look at and what strength you're going to discriminate against, so you can filter what you're looking at. Tests are just like archivers. You can put in arbitrary parameters and save them. And in the GUI supports any pscheduler 5 test possible. Jobs are new in pscheduler 5.0. So a job is just a set of tests that are run together, not necessarily in any particular order. Like Kaifeng was saying, you can put in the continue if statement, which is just saying, should I continue to the next job depending on the results of this job. So that's most useful for if you're doing layer 2 or layer 3 auth, you don't want to continue and try to do tests if the auth failed. Batches, you can set a sequence of jobs which will be run in order, and you can put it on a schedule to be run however frequently and choose which SSIDs you want to test, and then it'll run the jobs in order, and if one of them doesn't pass the continue if, then it'll fail and it'll send that to the ELK database. Hosts, you can set which Raspberry Pis you have in the field that you're managing, and then you can assign batches to each of the Raspberry Pis. And then you can assign to the groups as well. And there is an all group, which includes all of them. So all of that, when you go through the PSSID GUI, you're in the green area. Once you have a inventory created that you want to deploy, then you can go in to Ansible over SSH, and using a GitHub repository playbook that we wrote, you can then turn the inventory into config files and push them out to all the Pis, and it'll create a custom config for each Pi and push it to all of them. And then you can log into the ELK dashboard and see the new tests that you've configured. You can see those results right away.
So right now, we have a proof of concept of this running in our lab. We're looking forward to doing a further deployment here on campus. Right now, our environment is not what we would like in order for it to be in production. There's a few reasons for this. Right now, we're sort of on the bleeding edge of perfSONAR 5.0. We're testing some of the new features. We're discovering bugs. We're fixing the bugs. We're contributing them back to the perfSONAR consortium as bug fixes. And basically, because the Raspberry Pi is an ARM processor, we prefer to run Ubuntu on it. We tried running CentOS, but they just didn't have package support for CentOS on an ARM processor like they do on the x86. We had a lot of package dependency problems. So we've discovered that Ubuntu works pretty much straight out of the box. So PSSID requires perfSONAR 5.0. The Raspberry Pi prefers Ubuntu. So we need to run perfSONAR 5.0 on Ubuntu. That is coming. Like I say, we're at the beginning of the release cycle of perfSONAR 5.0, so we sort of predate the Ubuntu 5.0 cut. When the Ubuntu cut is available, our plan is to move everything to the official Ubuntu cut, and that will pretty much finalize our deployment, at which point we'll be able to verify that everything that we have works, and release the playbooks, roles, and software that we have developed this summer to accomplish this testing. Future developments, we're going to do more dashboards and alerts via Kibana. We're going to get the data into the ELK stack, and we're going to do data analysis on it. We're going to take advantage of an emerging feature in pScheduler. pScheduler is able to give test and archiver specs via a REST interface. Right now, that's not currently populated, but there will be an effort that takes place to populate that. The upshot of that is that programs that describe tests and archivers, namely us and PWA, there may be others that emerge, are able to dynamically generate web pages that show the available options for those tests and tools and archivers. We have structured PSSID internally in order to take advantage of this. And as the support for that emerges in pScheduler, we're well positioned to take advantage of it. We're going to support multiple interfaces. So getting it to work with just one wired and one wireless interface was quite the challenge. Now that we've got that and we have a better understanding of how the network interfaces interact, we're looking forward for multiple Wi-Fi interfaces. This is a pretty robust platform, very healthy. We could use it for things other than just PSSID. We could use it for packet capture platform with a 64 gig card. And we're also adding monitoring for the monitor. We're going to add, service status checks, hardware checks, availability checks, some checks in the ELK dashboard to make sure that the data is flowing and hasn't been ceased for, the probe says it's there, but it's not actually sending any metrics. And this has been the culmination of a very large effort. This is the third year we've been developing a wireless solution that uses PSSID or that uses perfSONAR. I could spend the next 10 minutes reading off all of these and probably get half the names wrong. So I won't. Instead, I'm just going to say that we have a esteemed list of alums that not just alums of University of Michigan, but alums of the project. And we appreciate all their help. And there are some unsung heroes that don't make this list, but it's an oversight. It's not meant as an exclusion. So with this, we sort of concluded our main presentation, and we would be more than happy to field any sort of questions about the work that we've done here this summer.
All right, well, thank you all for going through that. Looks like we've made a lot of progress this year, even from last year's results. So I'll remind everybody, if you do have questions, you can either raise your hand and I can unmute you if you're in a quiet area, or just type your question into chat, whichever works best. I got a couple questions that can get us started here. Are you at the stage yet where you're looking for beta testers? I see many familiar names and of people that are out there from various campus installations of all shapes and sizes. Would that be helpful for understanding how this works out in the wild, or do you have a pretty robust deployment on campus right now?
Our campus deployment is in the infancy. We have about a dozen probes that we're going to be using as a proof of concept around campus. We're going to be using that as a test bed to develop the dashboard metrics that we need for ELK. Right now, we kind of have the provisioning and backend systems in place, and we're going to be working more on the actual deployment and the integration with the data stack. Our deployment, we hope to have it finalized this fall. Part of that is waiting on perfSONAR 5.0 to stabilize on Ubuntu. And then at that point, we'll be releasing all of the software, all of the provisioning mechanisms, and we would very much welcome the opportunity to have other beta test institutions. We would even go so far as to, we could collaborate to help people get their initial deployments up and running. That would be an educational experience for us, and it would be an opportunity for us to refine our deployment practices.
Okay, so if anybody out there is interested, certainly drop me a line and I'll make sure I can get you in contact with with the team in Michigan later on this year or even early next. So I'll direct the next two questions towards Kaifeng and Benton. So Kaifeng, I'll start with you first. Before you started this project this year, were you familiar with perfSONAR? And if you weren't, what were the easiest things and the hard things about trying to get up and running on this platform?
The easiest thing for me is that I understand so there is like a lot of support coming from the community, and I got like a lot of support from Mark, and not only Ed but also Mark, which is from Internet too, and he onboarded me with like whenever I had any questions, I always turn to Mark, so I'd make the onboarding process way easier. And the hardest thing would be that making the piece scheduler running on different platforms. So we had to navigate a lot of details, inner details about like Linux and all like basic and lower level implementation, even lower level implementations of the system. So, and yeah, that's pretty much it.
Okay, thank you. And then I'll ask the same question to you, Benton. If you weren't familiar with it, or even if you were, what were the easy things about getting started and what were the hard things?
I was also not familiar with it at all. The easiest thing is that all the perfSONAR stuff has really good documentation. And then, like I think said, you have like the community is really helpful, like Mark Fight. Those were the easy parts. The challenging part was, for me, I was unfamiliar with Wi-Fi monitoring basically, so just learning that stuff. But I mean, that's fairly not really related to perfSONAR, just in general. But yeah, the documentation is really good. That's the main thing for me.
All right, well, thank you both. And we have a question that came in from Brian. And hey, Brian, nice to see you again. Will there be an option to syslog polling results as an alternative to using an elk stack?
Yeah. So, oh, we're getting echo? Oh, okay. Yeah, so you can, any of the archivers that work with pscheduler work with this. So you can use syslog, elk stack, arbitrary HTTP requests work as well. Any of the pscheduler archivers work. So yeah, syslog works in addition. And you can configure it all through the GUI.
All right, thank you. And hey, Jeremy. You mentioned the need to test against multiple PSSIDs, or at least the difficulty of testing against only a general SSID. How are tests scheduled across PSSIDs, both for a single Raspberry Pi and across the entire perfSONAR system for a given test set, or for a given set of test batches?
So yeah, let me take a look at a question just for a minute.
Yep.
For a single Raspberry Pi, we'll be scanning. So in the definition, in the test definition, configuration file definition, can be giving an SSID. You'll be putting that SSID in the config file, and when pieces runs, after it has scanned through all of the surrounding pieces, because each of the pieces is also associated with this SSID, right? So according to if this SSID is defined in the configuration file, we will perform the designated test for this PSSID as according to if they are belonging to the test definition. And so all these pieces are equal in terms of what the test will be given. and according to which SSID they are on. So, and what about across the entire perfSONAR system? Ed?
So are you muted?
Oh, yeah.
So we're all in the same room, so we have a terrible echo sometimes. So as Kaifeng was saying, an individual probe knows about SSIDs. So if it scans an area and finds a BSSID that corresponds to a known SSID, it has the credentials to potentially test that BSID. It's impossible, or at least very hard, to know which BSSIDs are in an area. So you scan and then you correlate them with known SSIDs. Enterprise-wide, you would have, like, for instance, Eduroam and M-Wireless are enterprise-wide SSIDs here on the University of Michigan campus. So you would know ahead of time your enterprise-wide SSIDs. You would put them in the config file, and you would push that config file to every Raspberry Pi. So, or potentially, I mean, you could do a subset, but the power of this is that you can then push to every single one of them. So if you became interested in Eduroam and you weren't previously, you could push that to all the Pis, and some of the Pis would potentially say, hey, I see Eduroam BSSIDs in my area. Some of them are strong enough signal strength that I can test. I have the credentials, so I'm going to not only passively scan and note their existence, but I will actively test them with these credentials and return the performance metrics back to my data repository. If you're in an area and, for instance, you're interested in Eduroam, and there are no Eduroam probes in that area for that Pi to scan, then that means one of two things. Either everything is going right and there should be no Eduroam APs in that area, or that was not what you were expecting. You were expecting one or more, or if you scanned one, you were expecting more than one. And in that case, the scanning and the testing would unveil a shortfall in redundancy that maybe you would have expected.
All right. Thank you for going through that, Ed. Next question, and I'm sure a lot of people want to know this. Where did you find your Raspberry Pis to purchase? If you purchased them recently, or if you're working off of an old inventory?
I'd like one of the interns to answer this.
We're working on Raspberry Pis that were purchased previously, but now they're more expensive. They're more expensive, but in the future it'll go down, presumably, once the chip shortages stop happening. So, but now's a good time. If you guys have Raspberry Pis, now's a good time to sell them, you know, just saying, and then just buy back cheaper ones next year.
Yeah, as I look at my stack of old Raspberry 3s here, I wonder if I can put them on eBay and make a little bit of cost recovery there.
Exactly. Yeah.
All right. Well, we are out of questions for right now, so I'll put out another call if anybody has. Oh, there we go. Thanks, Brian. Did you list all the metrics you are checking on the passive scan?
I'm going to ask Kaifeng to dig them up. And while Kaifeng is digging them up, I will say that Benton is available for an advisor on your cryptocurrency investments as well, not only your Raspberry Pi investments. And I will turn this one over to Kaifeng.
So the metrics that we gather from the Wi-Fi B6 scan tool includes like channel frequency and signal strength. And let me look if there are other metrics as well.
You can share your screen.
Yeah, sure.
And then as you're doing that, Brian notes they are tracking our SSI and SNR.
Oh, okay. So these two metrics are not covered by the tool, but we can look at like additional solutions that can support to like gather the metrics for these two metrics as well, because we are using a tool, WP Supplicant, to do the Wi-Fi visa scan, and we are using the scan feature to gather all of these network metrics and SSI, RSSI, and SNR. And we can do additional research on these two metrics, and hopefully we can integrate them into a system in the future.
So my comment on that is, if RSSI is just signal strength, then we are providing that. We're pulling that metric off of, it's provided by the operating system. It provides us a list of the PSSIDs that we scan with a relative signal strength. If that's RSSI, we've got it covered. Tools that track things like signal to noise ratio. The way I look at it is like this. So a couple of years ago, we looked at the limits of doing traditional network testing, like perfSONAR, throughput and latency, and how that applies to Wi-Fi. And when you look at Wi-Fi, there's a whole nother layer of difficulty, with competing APs and all this other stuff. And it ends up where it looks like the tools slot into two categories. If you have a tool like Horst, it seems like a lot of those tools are interactive. They have user front ends. They're a real-time faux spectrum analyzer. And those you pretty much have as a standalone tool that you can use interactively. And there's not really a great usage case for how they could be incorporated into perfSONAR. Now, if you have a different tool, something that you can run non-interactively via the command line, and it returns a metric. So you execute it, you either set up a series of conditions or you give it some options, it does its job and it returns a metric. Well, in that case, that would be an excellent tool for a candidate for inclusion in perfSONAR. And just so that you know, there is a thing called a plugin development kit where you're able to take third-party programs, archivers and tools, and incorporate them into perfSONAR. I'm not going to say painlessly, but I will say that it will ease the pain of the inclusion of a third-party tool into perfSONAR. So if you want some analytic capabilities that do not currently exist in perfSONAR but are available via a command line tool, that is one option to get that type of metric gathering into perfSONAR, get it automated, get it on the schedule, and get it into your data visualizer.
Right. Thanks for going through that process, Ed. And I guess my last question is, do you guys have a public GitHub? If so, maybe plunk that into the chat room if you're ready to share that with anybody. If not, certainly don't worry about that step.
When we started this endeavor, we sort of actually started before June. We kind of had the idea that this would be the internship, and we hired candidates and we laid out expectations. And just like everything else in the last 2 years, estimates were not conservative enough. And we're in a position right now where we have proved proof of concept. We're still working out a couple of the bugs in between PSSID and perfSONAR. We're waiting for perfSONAR to show up in Ubuntu 5.0. And we are on the cusp of publicly releasing this. Some of the stop gaps are ours, development challenges. Some of them are out of our hands. Like the platform we're using now is not something I would recommend anybody to try in production. It's a hand-built distro for the Raspberry Pi that we're using. When Ubuntu on the Pi for perfSONAR comes out, and we've worked out all of the interactions between perfSONAR, PSSID, and the new perfSONAR abilities like the batch processing and the new tests, we will be releasing this immediately. It's our belief that that this software, it's our hope that this software is useful here at the University of Michigan. It's our belief that if this software does generate the metrics that we hope to, that it will be of use at other institutions, and the usage case, each usage case will be different enough that it will contribute back to our body of knowledge, make our own usage case more robust, and you know, remove other barriers to its deployment. So we're looking very much forward to that. And this is not a theoretical talk, even though there's no software being distributed right this very moment. It will be shortly, once the blockers that we've noted are removed.
All right, sounds like a plan. So last call here, and just to follow up from Brian, they mainly use WLC metrics, so it's relatively easy to collect, but having probes that we can optionally deploy to get client-side perspective will be a great complement to the WLC client connection data.
So part of the philosophy for what we're doing is that we're trying to complement some of the traditional top-down monitoring. So we have a Wi-Fi team, and they have you know, anywhere from open source to proprietary products and tools, and they provision from the network backbone to the last mile of the wireless internet. And what they can do is, from the top down, they can verify things like configuration and connectivity and stuff like that. But what we've had and we've noticed is that as previous slides, especially the intro ones that Kaifeng presented, show, that when you get into a very distributed, very complex campus situation, it's not just a matter of connectivity and verifying component infrastructure. You end up in situations where, you know, you might have a problem that you have no control over, like your IAM situation has an outage. So even though all your components are available, your networking to those components is available, you're not able to get on them. And you wouldn't be able to tell that from a top-down perspective necessarily if you were just on the networking team. However, your users are not able to use your service. So if you have a probe in the field that is indistinguishable from one of your users, it's going to suffer the same type of difficulties during outages that are invisible to you, that affect your service. So if your users are having a problem, these probes are going to be coming in on the exact same authentication mechanisms, the exact same component infrastructure, and they're going to give you your user perspective, hopefully before enough of your users do.
Yep. Brian says good points. He agrees, and I think that's a good summary as well.
I will say that this is painfully hard-won knowledge. So anybody who's run one of these systems knows that it's difficult to sleep well at night. So.
Especially when you're the one that's holding the pager when the campus Wi-Fi goes down.
Exactly.
All right, well, I'll put out the last call for questions here. If anybody has anything else, please do. And a note on scheduling here, no talk next week, but on the 5th, 2 weeks from today, we're going to have Ken Miller from ESNet talking a little bit about data mobility. So anybody that is interested in that topic, that'll be next. And then on the 12th, we're going to have Michael Sinatra talking about all kinds of cybersecurity and information security topics. And it looks like we may be out of questions. So I will thank Ed, Benton, and Kaifeng again for an excellent talk. We'll make sure we get this video posted. And hope to see everybody again in a couple of weeks. We'll talk to everybody soon.
Thank you, Jason, for the opportunity and the venue.
Yep. Thanks all.